On the practice exam, the first word problem is a genetic question about a cross between two individuals. So you're told that Mickey Mouse has a genotype big A, little a, big C, little c, big F, and Minnie Mouse has a genotype big A, big C, and big F, F. So the first part of the question asks, list the possible gametes that Mickey and Minnie can produce. So remember that gametes are haploid, and they're the product of meiosis. So each gamete will only get one of the alleles for every gene. So for example, Mickey will make a gamete, and that gamete will either get A or big A or little a. So one possible combination can be big A, big C, big F. Another possible combo is little a, big C, big F. Another combo is big A, little c, big F. And the last possible combo is little a, little c, big F. You see that for each gene pair, or for each gene, you only get one of the alleles in the gamete. And this is true because a gamete has to be haploid, because it'll then undergo fertilization with another haploid to create a diploid zygote. So that's the answer for Mickey. For Minnie, the gamete is a little bit simpler because she's homozygous dominant for all of the genes. So the only gamete that she will make is big A, big C, big F. In the next part of the question, it says, assuming independent assortment for all gene pairs, what is the probability that Mickey and Minnie will have a baby mouse that has the genotype big A, big C, little c, big F, F? There's two ways you can do this. The first way is you can look at each gene independently and then multiply their probabilities together. So first let's look at the A gene. We draw a Punnett square with Mickey and Minnie's genotype. And we see that the probability of their baby mouse being big A, little a is 1/2. 2 out of 4. You do the same thing for the C gene. And you see that again, the answer is 2 out of 4, or 1/2. So you write that over here. And lastly, you do the F gene. You don't necessarily have to do a Punnett square for this one, but I'm just going to do it just to prove the answer, which is no matter what, their kid is going to be big F, F. So the probability of the baby mouse being big F is 4 out of 4, or 1. And remember, these are all independent events because these genes independently assort. So you multiply the probabilities together, and the answer will be 1/4. That's the probability of their baby mouse having this genotype. There is another way to do the second section of this question, and I'll go through that. And if this way makes more sense for you, you can do it this way. So you're looking at the probability of the baby mouse being big A, little a, big C, little c, big F, big F. So this second way involves looking at the gametes. You still draw a Punnett square, but you're going to list the gametes. So we go back to the first part of the question, and the gamete that Minnie produces is big A, big C, big F. The possible gametes that Mickey produces, you list at the top. And so this Punnett square is a bit different from the other Punnett square that we did, but the concept's the same. When you fill in the boxes, you just combine those haploid gametes together. And that's the complete genotype of that cross. So it's up to you if you'd like to do it this way or the first way that I explained. Either way will give you the same answer. And you can see doing the Punnett square this way shows that the possibility of the baby mouse having this genotype is 1 out of 4.